Hello, this is question 3 from the step 3 paper in 2022. Start off here then. Curve C1 has that equation. A, B and C, none of them are 0 and A is greater than 0. Show that if the curve has two stationary points, then we have that inequality. Right, clearly I'm going to be differentiating then if we're looking at stationary points. So, well, I'll differentiate with respect to x just because it just seems a bit more natural, but it doesn't really matter. You could do it with respect to y, but I'm not going to. So 2ax plus by plus bx dy dx plus 2cy dy dx equals 0. And then we're looking at stationary points. So stationary points. So that means dy dx equals 0. So I'm going to get 2ax plus by is equal to 0. So y is equal to minus 2ax over b. Let's go back to the original equation then and sub that in. So that is going to give ax squared plus bx times minus 2ax over b plus c times 4a squared x squared over b squared is equal to 1. Okay, so I can cancel that and that, make that an x squared. So I've got ax squared minus 2ax squared. So I've got a minus ax squared equals 1, and then I've got this thing. So I've got a well, let's multiply everything by the b squared. So make that a b squared there, put a b squared there, which leaves me with 4a squared c x squared. Right, so that all looks pretty good. And I want what? I want two stationary points. So two solutions means, well, this is just a quadratic in x. So in inverted commas, very much so. In fact, we're using b's, a's, c's everywhere. B squared minus 4ac has got to be greater than 0. So b squared, there aren't any b's. So I've got to have minus 4ac. Well, c is going to be minus b squared. So I'll have 4b squared. And then I need to multiply that by a, which is going to be 4a squared c minus ab squared. Has got to be greater than 0. Okay, so, well, that bit's greater than 0 already. I can divide by a, and a is greater than 0. They've given that in the question, so that's good. So where a is greater than 0, so let's put that all in there as well. So that means that 4ac minus b squared has got to be greater than 0. And there we go. So that's just dropped out. So that was a nice starter, just to warm us up. New sheet. Curve C2 has got this equation. Right, so I'll write this out again because it's quite small. AY cubed plus bx squared y plus cx equals 1. So ABC, again, none of them are 0. This time b is greater than 0. Show that the x coordinates of stationary points on this curve satisfy that. Right, so I'm doing the same thing again. Differentiate with respect to x. You know, doesn't really matter again which one, but I'll differentiate with respect to x. So I'm going to get 3ay squared, I'll just do a y dash this time rather than doing all these dy dx's, plus bx squared y dash plus 2bxy plus c equals 0. So again, I've got y dash is equal to 0 is going to give that 2bxy plus c is 0. So y is minus c over 2bx, which is a little bit ugly, but there we go. So let's stick it back into here. So I've got a times y cubed. So that is going to be minus ac cubed over 8b cubed x cubed. Then I've got a plus bx squared times y minus c over 2bx. So that's got a bit of cancelling there. Plus cx is 1. So get rid of that and that. Get rid of that and that. So I've got cx, so minus cx over 2 plus cx. Okay, so I've got cx over 2 minus ac cubed over 8b cubed x cubed is equal to 1. So clearly I want to multiply by this 8b cubed x cubed. So I'm going to get 4b cubed c x to the 4. Okay, and then I've got well, this thing is just going to be a minus ac cubed, and that's going to be equal to 8b cubed x cubed. Right, so this should hopefully be fairly close to the answer. That is that first term. Well, that's the last term, and that's the term in the middle. So yeah, just got to rewrite it in the order that they've done it. So 4cb cubed x to the 4 minus 8b cubed x cubed minus ac cubed equals 0. Okay, right, so that's probably filled up too much of the screen, is it? For when am I going to get this in? Show that if the curve has 2 stationary points, right, that's going to take a lot of doing, I think. So I'm going to get a new sheet for that. So at least the result is already sitting here. So based on this, I need 2 stationary points. So there's a stationary point at each solution of that. So there's 2 solutions to this quartic. So 2 solutions, so I remember what I'm doing, to the quartic is what I want. And what sort of quartic have we got here? 4cb cubed. Right, so it's going to depend on c as to whether it's positive or negative. We know that b is positive, but we could have, we could have this either way up. So how do I get 2 solutions to a quartic? How many different options have I got on this? So I could have, let's just draw positive ones first of all. Actually, I don't need the y-axis on there if I'm just looking at the solution. So I could have, that's got 2 solutions. What else could I have? I could have a point of inflection and then a minimum. That's got 2 solutions. Also, I could have the point of inflection on the other side. That's got 2 solutions. Or I could have that, couldn't I? I could have 2 points of inflection. So that means I've got 1, 2, 2, or 3 turning points on this. So I need to interrogate this thing. So let's say, see how many turning points I've got to this quartic. So let y equal 4cb cubed x to the 4 minus 8b cubed x cubed. Actually, I'm going to put a note up here. So that is c greater than 0 or c less than 0, because we could have negative quartics. That might make a difference in all of this. What was I doing? Oh yeah, minus ac cubed. So y dash is going to be 16cb cubed x cubed minus 24b cubed x squared. And then y double dash is going to be 48cb cubed x squared minus 48b cubed x. Okay, so how many turning points have I got? I'm probably going to have 2 here by the look of it. So I've got x equals 0 is a turning point, and I've got, okay, let's write this out down here again. So y dash is going to be, let's take out an 8, let's take out a b cubed, let's take out an x squared. So I've got all of that, and then I've got a 2, a c, and an x, and then I've got a 3. Okay, so turning points, yeah, I've got 2 of them, so it's not going to be that one or that one. So I must have a minimum or a maximum if c is negative and a point of inflection. So I've got turning points at x equals 0 and x equals 3 over 2c. Okay, right, so what am I going to get for these inflections then? I mean, this thing here, I can take a 48, a b cubed, and an x, and then say I've got cx minus 1 on there. So when x is 0, that's going to be my point of inflection. And the other one is just going to depend on whether c is positive or negative. So I've got inflection at 0. When x is 0, y is minus ac cubed. And I've got a min or a max at 3 over 2c. And then what happens when I put 3 over 2c into here? This is going to be a real mess, isn't it? I'm going to have, God, it really is. So that's 4cb cubed, 3 to the power of 4, so that's 81. And then that's going to be divided by 16 c to the 4. Yeah. Okay. And then I've got minus 8b cubed times 27 over 8c cubed. Okay, right, so at least I've got something cancelling there. And then I've got minus ac cubed. So I'm going to lose, let's do some cancelling in some blue. Get rid of that, get rid of that, get rid of that, make that a 3, get rid of that, make that a 4. So I've got a b cubed over c cubed, 81 over 4. So that if I change to 27 over 4, that would be 108. So I've got minus 27 over 4. Okay. So minus 27 over 4 b cubed over c cubed minus ac cubed. Right, that's fairly ugly looking. So what am I saying then on this? I've got one of these things. So if c is negative, right, let's go with this. So c is negative, right, then that means I've got a maximum is on the left. So I'm going to have something that looks like that, yeah? That's got to be right, isn't it? That's my two solutions. And this maximum, that's going to be less than 0. If c is positive, then I'm going to have the minimum on the right. So I'm going to have something that looks like that. Right, so they're my two options on this. So, right, so what does that mean? What does that mean? That means, well, I just have to look at these y coordinates, don't I, and say that that thing's got to be positive. So I've got minus 27 over 4 b cubed over c cubed minus ac cubed has got to be greater than 0. And for this one, I'm saying that minus 27 over 4 b cubed over c cubed minus ac cubed has got to be less than 0. Right, so how close is that to the answer? I've got a 27b cubed. So, oh, and I've got a 4ac to the 6. Yes, but in this case, when I multiply, it's going to flip the sign because I'm multiplying by c cubed. So this one will go to minus 27b cubed, then multiply everything by this 4c cubed. So I'm going to get minus 4ac to the 6 has then got to be less than 0. And when I do this one, I'm going to get the same thing. Minus 27b cubed minus 4ac to the 6 is less than 0. So that is what I want. I just need to write it the other way around. Right, I got all that. I really like that bit. That was a very, very pleasing bit of work to do. Right, so now we're on to these simultaneous equations. So in part 3, so let's get a blank sheet up for that. Consider these simultaneous equations. Right, so given us the same one here. That's the same. Wonder what I picked the others. A, B, C not 0, B is greater than 0. So it's the same setup that we had here. Show that if these have got a solution, then we've got that thing holding. So what were the other ones? Have we had these in the previous part of the question? 2bxy plus c. Yeah, that was the, I recall that. That was somewhere in this, wasn't it? 2bxy plus c. Maybe it wasn't. Actually, this is the second part of it. Maybe I don't want to look at that one. I'm going to look at this one. Here we go. 2bxy plus c is equal to 0. So that's come off of the turning points thing. And then I've got this 3ay squared plus bx squared. All right, so it's the other part of this in here. So they've pulled out the two equations here from this turning point setup. Right, so it is a straight follow-on then from the previous bit. Right, so we just have to solve these, which isn't hopefully isn't going to be that bad, really. I mean, this is kind of standalone. So even if you hadn't done the previous parts, you probably could have worked your way through onto this one. So let's go with what seems to be a sensible way of. There's a lot of similarities here between these first two, aren't they? So let's call that. So 1, 2, 3. I'm going to do 2. Equation 2. I'll do it multiplied by x. So I'm going to get 2bx squared y plus cx is equal to 0. So if I now do, let's call that 4. So if I do 1 minus 4, I'm going to get ay cubed and then minus bx squared y is equal to 1. So that looks good because I can now say that x squared is going to be ay cubed minus 1 divided by by. So I've got what x squared is. Now I might as well pop this into 3, and that will give me, it'll give me something to do with y anyway, won't it? So let's pop it into 3. So into 3 is going to give me 3ay squared plus, well, the b's will cancel. So I'm going to get ay cubed minus 1 over y is equal to 0. Okay, so what does that leave me with? 4ay cubed is equal to 1. So y cubed is equal to 1 over 4a. Okay, so that means I can now get x from, well, I haven't used, what have I not used yet? Well, I can put it into 2. That'll be fine. So I've got this from, well, I've used a bit of everything, but yeah, let's go for 2. 2 looks like quite a simple one to put it back into, I think. So let's go into rewrite equation 2. So if I've got, and I want to get a y cubed in it. So let's say that 8b cubed x cubed y cubed is minus c cubed. That's from 2. And then I can just drop this y cubed in, and that's going to give me that x cubed is minus c cubed. I need to multiply that by 4. No, yeah, multiply that by 4a, and then divide by 8b cubed. So all in all, I'm getting minus ac cubed over 2b cubed. Right, which is fairly ugly, but let's see where all this ends up. So I've got an x cubed and I've got a y cubed. So I'm going to need to put this back into one of these. Can't put it in 2, I've just dealt with 2. 1 looks like a complete, well, it's just too much going on in 1, although it does have a y cubed in it. But the other one, the 3, just looks simpler, doesn't it? It just looks like the easier equation. So yeah, let's put this into 3 then. So I'm going to have that I've got 3a times y squared. So I've got to do 1 over the cube root of 4a squared plus b times x squared. Yeah, that doesn't look very good, does it? X squared. I mean, x cubed looks horrible. So I've got the cube root of minus ac cubed over 2b cubed. Ugh, squared. And that's got to be equal to 0. Okay, so well, I can take this cb cubed bit out, I suppose, can't I? I mean, that b cubed is gonna cancel with that b. That c cubed minus c cubed, I can just take out as being a minus c. So I've got 3. I'm writing down the minus c bit. I haven't got to that. 3a 1 over the cube root of 4a squared. Then if I've taken that minus c out, it's still inside the squared bit though, isn't it? So that would be minus c squared by the time I've cube rooted it and then squared it, and then multiplied by the square root, cubed root even, of a over 2 squared. Right, so I'm going to want to cube these because then I can get rid of all these horrible cube roots. Okay, so if I cube all of this, I'm going to have a 27a cubed. Then I'm going to have this thing then squared, so over 16a squared is going to be equal to c to the 6 or minus c to the 6, and then I'm going to have an a squared over 2. Okay, so no, over 4. Right, so I can then do cancel that, and that, and then I've got multiply everything by 16, get rid of that, and then put a 4 there. So I've lost a whole load of b's somewhere. Where did all my b's disappear to then? So, because at the moment I've got 27 plus 4a c to the 6 is equal to 0. So somewhere I've not written down a whole load of b cubes. So where did I go then? So a has got, between a, where am I going? What did I do? I put stuff into here. Where have all my b cubes gone? These b cubes, I cubed root that. I had to square. So I would end up in here. Yeah, I got rid of my b's too quickly. I forgot about this square that I've got at the top. So that would be a b squared. So I had a 1 over b here. So that's a 1 over b. So where does that leave me in all of this? This would have been over b. So I could put a b here, which means I would then have a b cubed there. And then I'd have a b cubed there. Right, okay, just as well I said show that. Otherwise I would have lost all of my b's. Although having b's disappear would have made me somewhat suspicious, I think. But I've got a 4a c to the 6 plus 27b cubed. Yeah, is equal to 0. Right, okay, so that wasn't too bad. I mean, it was standalone. I know I made a little bit of a mess up in the middle, but at least I managed to rectify the situation. But this is standalone, this last part. You don't need any of the previous bits of the question. That was a fairly heavy algebra question, but it was quite a nice one. I like the deductive part in part 2. The first part was fairly straightforward. Part 2 was quite sneaky, and part 3 was just fiddly. So all in all, that was a pretty good question, I would say.